All right. Welcome to the session. Hi, everyone. So I hope you all had a great lunch break just now. And it is my honor to have your attention for the next 45 minutes. So before we start, I'd like to thank Moov and all the sponsors for having me in this amazing event and giving me the chance to present here. Thank you all. So today we're going to talk about how to reduce manual QA processes by utilizing AI agent. All right, so first a little bit self-introduction. My name is Peilu Zhang. I'm a senior data scientist at Spade, currently building out the AI and ML capacities there. Before Spade, I built a fee negotiation AI product for Harvest that was acquired by Acorns, where I also worked on data science and product team for almost 3 years. So personally, I enjoy yoga, creating content, and hanging out with my cats. So that's me. We can talk about anything that's mentioned here if you come and say hi. Cool. So first, I divided today's contents to 3 parts. So in the first section, I'm going to describe the problem that we've seen in our product development. And in the second section, I'm going to introduce to you 3 solutions that we've developed so far to solve this problem. And lastly, I'm going to summarize what we've learned so far. Cool, let's jump to the problem. So have you ever looked at your debit or credit card statements? If you do, then you know your transaction data is pretty messy. It lacks of the clarity and context for you to understand your spendings. As you can see here, often showing up as like jumbles of letters and numbers with, this is not working, with the phone numbers in the city field, as you can see one of the example, and a bunch of missing information. As many of you know, from trying to build a product on top of these data, you know your financial institution doesn't really know much more than you due to the poor quality of data getting sent over through the networks. So on top of that, one of the key issues with transaction data is the lack of merchant identity. So merchant IDs getting sent over the networks, they often unique to POS systems. Descriptors are often unique to locations. And businesses, they often share similar names. So without significant time and effort, it's really, really hard to link a transaction at a Target shop in NYC to a transaction at Target in Austin. So this creates lots of issues for financial institutions as well, including challenges identifying high or low risk merchants in fraud model, and also analyzing users' spendings and creating merchant log cards and more. This is a problem that data science team at Spade was tasked with addressing for our customers. So who are we? Spade provides real-time intelligence on card transactions by linking each transaction to a real merchant database that we've built and constantly updated based on our partnerships with a bunch of data providers. So one of the key responsibilities of our data science team is to maintain that database, ensure its quality, build links between different records, and also provide one of the fields that our customers found most valuable, what we called counterparty ID, so which is a unique identifier for each location of a merchant. For instance, Starbucks. So every Starbucks in US should have only one counterparty ID. And we call this process counterparty clustering. But as many of you know, try to do that. You might know that this is not easy. Let's take a look at why together. So first, you might ask, how about using MIDs? MIDs are also known as merchant IDs or acquire IDs. They are thought to be the way to solve this problem. However, as I just mentioned, MIDs, they are unique to POS systems and also sometimes channels. So the online Target shop will have a different MIDs to every Target locations, and sometimes even checkout lines. So we've seen that more than 9,000 MIDs for Target only. And we also see like more than 15% shifts quarterly in MIDs. So mapping MIDs to clusters and also keep them up to date requires lots of QA as well. Cool. Now let's bring it to life. So I listed 4 transactions here. Does anyone want to guess which ones are the real Target transactions? Shout it out. OK, I hear 3. 1. OK, I hear 1. How about other people? Want to guess? OK, I hear 3. I hear 1. And also, it does take some time, right, for you to think which one is the real Target transactions. 4. I hear 4. Hmm?
It's got to be because it's not related. You can't tell it.
Yeah, but that's actually, I just listed 4, and then I listed 4 of them, and the 4 is the most different one, so that's why you choose it, right? Yeah, that's a good strategy. So also, different people might have like different standards, as I can see. Like people choose 1 or 3 or 4. Let's see. So this is the answer, 3 and 4. Congratulations, you are right. So 3 and 4, they are actually transactions from Target, the department store. So the first one is, unfortunately, an inspection company. That's called Target. And the second one is nobody guessed it because it's a gun shop. And we noticed that a lot of gun shops, they include Target in their names. So if you say, hey, how about using regex? It won't work because of like a lot of these examples exist. So it will create false positives and false negatives. So don't use regex. Cool. After our team review those transactions and their addresses, we will cluster the real Target's locations to a cluster and then assign them a unified counterparty ID. And that's the counterparty ID for Target. We won't change that. And for the other 2, we will assign 2 different other counterparty IDs for them. So the goal of this whole clustering process is to ensure that every location, every Target location, regardless of MIDs, they will only share one same counterparty ID. So today, all Targets have only one Spade counterparty ID in our system. Cool. So this is a problem. You might also recall some similar problems during your product development. We call this data linkage problem. This isn't unique to transaction data. In finance, we always have the problem that is like customer profile unification. And also in healthcare, we've seen patient record integration. Also in social networks, we have the identity resolution problem and more. So what do? Oftentimes, significant QA efforts are required. Cool. So now let's move to the solution part. In Spade, we developed 3 solutions to tackle this problem. manual QA, programmatic QA, and LLM QA agent. So today, I'm going to walk you through the evolution from manual QA to programmatic QA, and then I will introduce the how we develop a workflow to create an LLM QA agent. All right, so manual QA. This is the first and the most basic approach that we've tried. So we have a group of contractors. We have this team to look through the records that could theoretically belong to one of the high priority counterparty cluster. And they will manually determine whether to cluster them or not. So we have like very strict instructions and rules for them to follow to make sure achieve a very, very high QA accuracy. In short, the process is analyst receives the counterparty pairs QA table. This is a table, and then they will conduct the process like this GIF showed you. The analyst will enter the address in the Google search or maps, find their websites and descriptions. Then after they gather those information, they will digest them and determine if they have sufficient similar information. And lastly, they will label the pair using 0, do not cluster, or 1, cluster. OK, so pros and cons. For manual QA, human can catch some edge cases, and humans often have like a pretty high accuracy. However, this is definitely a pretty time-consuming process, and it is expensive. Also, it can be inconsistent, as you can see in the previous example. Like different people might have different standards, use different information to label the data. However, in Spade, we train our contractors very strictly to follow the instructions to achieve the high standard of data accuracy, because our customers, they use our data to make very, very crucial business decisions. So that means we need to spend more time and more money on QA. Moreover, it's not scalable. So as you can see, we have like a sheer numbers of businesses in US, and they often change their names or change their entities very often. So it is not scalable based on manual QA to finish this QA process. Cool. So how can we make this process more scalable, cost-effective, and faster? So that's the second approach that we chose. We moved to the rule-based programmatic QA. So basically, this method will allow us to label millions of data pairs in a very short period of time. On a high level, the process is, so we create some predefined rules. For example, counterparty names should be the same or similar enough. At the same time, the pairs should share exactly the same phone numbers or legal names or websites. So here's an example of McDonald's. You can see in this table the 4 McDonald's locations, they share similar enough location names. At the same time, their legal names are exactly the same. McDonald's Corporation. So in that, we're pretty confident to cluster those 4 McDonald's to the McDonald's, the fast food cluster, and assign them a unified, consistent counterparty ID. Cool. Rule-based programmatic QA is fast, and it allows us to label lots of pairs in minutes, and also very explainable. If our stakeholder asks us, hey, why would you cluster those 2 together? We can easily explain that to them. And also, it's pretty cheap. However, This method relies heavily on data accuracy and also the field coverage of the underlying data set. For instance, if a website in your data set is wrong, and you use that as a rule, so it is likely that one of the counterparty will be misclustered or mislabeled. Also, if you use phone numbers as your rules, but you only have a very spotty phone number coverage in your underlying data set, the overall labeling percentage will be low. So that is it is constrained, this method. The overall efficacy of it is limited. All right, so how about building a model to predict pairs? Naturally, we just move to the next approach, classification. So we train a classification model to predict the rules for the pairs. Generally, the process is we label a few thousands of pairs, then we generate features for those pairs, and then we train a classification model to predict labels. So this table is like a pseudo feature table that we created. So you can see we include merchant names for those pairs as one of the feature, embeddings of those merchants, and also name similarities and embedding similarities. So you might ask, what is embeddings here that you use? All right, so this is on the high level how we generate our embeddings. Basically, we compel, we generate embeddings based on several features of a counterparty, business name, website, industry descriptions, MCC, legal names, etc. We compile them all together and then send the text to OpenAI to fetch the embeddings from one of the OpenAI embedding models. After we get the embeddings for each counterparties, we can calculate the similarity scores for them. So the embeddings can help us to evaluate similarities more accurately and also increase the classification efficacy overall. Cool. Now let's review the pros and cons for the problematic QA classification model. So the pros is, one of the pros is it is fast to label pairs once the model is trained. And also, we gain more flexibilities comparing to rule-based models since the semantic meaning is captured by embeddings. However, for the data with new or dissimilar embeddings, it is still difficult for us to predict the labels. Plus, fetching the embeddings and calculating similarities can be slow and costly. And lastly, because it is a model, we can't really trust it 100%, and because our very, very high data accuracy standard, we still need some human QA to ensure ensure the accuracy of it. Cool. So far, we learned that ML model, they can only learn from the data that we provided to them. They do not think or reason like our data labelers, nor they can go to a website and look up information online, right? So this creates a problem because when our labelers, when us, we do QA, we need to think, we need to process the information that we get. At the same time, we will search online to enrich the information and then make the final decision. So how do we automate the process furthermore? We choose to use LangChain agent with tools to work, think, and take actions like a human at a machine pace. Isn't that great? So what is an agent? I think most of you in this room, you may already played with it, but I'll just give a very short description of what is a QA agent. The AI agent is generally a smart program that can understand humans' input and questions. Then they can make a decision, and then they will execute the actions, conduct the task on its own to achieve certain goals. And also, it can be better at what it does over time. So now I will show you our approaches, outcomes, and tips, and then also how to apply that to your own problem. Cool. So the first part of defining your agent is to define a system prompt. That's very important. So in these examples here, we divided the system prompt to 4 parts. In the task description part, you should provide your agent with enough context for it to understand what to do. And in the second part, we provide like the step-by-step instructions for our agent to execute. And then in the third part, we tell our agent what is the desired output that it should return to us. And lastly, important part, we add this part because we noticed that sometimes the agent will hallucinate. It will just return something else instead of the expected output format. So that's why we constrain it to only respond things that we want. Except for that, you can also encourage your agent to think, observe, and take actions, which is actually the React prompting format. We will discuss that later. Cool. Before we move to the next part of creating an agent, let's pause here and reviewing some tips of writing good prompts. So I listed 6 of it, but feel free to add more into your agent development. The first one is to be clear and specific, as we discussed. So I listed the example here in the task description part. Be clear and specific can be give your agent a role and tell it what is your goal, and also ask it to follow the step-by-step instructions. Also, you can ask your agent to summarize the reasons behind the answer. The second part is to include some examples, which is called few-shot prompting. So in this prompting, you can include few examples in the system prompt for your agent to better understand your task requirements. And the third one is to use proper eliminators. For example, when you include some examples in the system prompt, you can use Markdown because GDP can understand it pretty well. It is trained on GitHub. Also, to please clearly indicate the distinct part of user input from the other part of descriptions. Use the eliminators. All right. The first one is always ask for a structured output. We'll touch on that later. The fifth one is to be aware of prompt leakage. What is a prompt leakage? So basically is whatever you put in your prompt, it is likely that other people who's using this agent will get that information from your system prompt. So you might say, hey, how about add some constraints? For example, I do not release this information. Tell that to your agent. But it's not that smart yet. So a simple reframing of the question can still get it spill the beans. So basically, do not put any sensitive information in the system prompt if you don't want to release them. Last but not least, be concise. Due to token limits, so based on the models that you choose, it is around 28K token limits shared between your prompt and your completions. So yeah, be aware of it. If unfortunately, you need to write a very, very long text for your agent to execute, you probably won't need to include the examples. Just use zero-shot prompting to avoid exceeding that token limits. Cool. All right, the second part, define the output. So for the output, the same thing. Let's just specify the output format in the prompt, and then you can use the output parser. Here we use the LangChain output parser so that we don't have to worry about converting the string to JSON. So this is an example of asking a desired output. You can say something like, return the answer in JSON format, and please strictly follow the schema. And in this part, yeah, I'm using delimiters as well. Include a example to help your agent to understand what is the desired schema. And then if you run this prompt, you will notice that it is returning a string instead of a JSON. So use LangChain output parser, and you don't have to worry about converting that to a JSON. All right. So after we define the system prompt and output schema properly, let's create our agent. So LLM is like the brain of your agent, and tools, they are like arms and legs for your agent that can actually execute on what LLM decide to do next. So define the agent, define the LLM. You also have to define the tools for your LLM that has access to. In our case, we define Google Maps and Google Search as the tools for our QA agents. For you, it might be anything. You can also create the tools, customize the tools to tackle your problem. Also, you can select agent type. So LangChain, they provide 5+ LangChain types. Here we chose the zero-shot React agent. So what is React agent? React is actually a prompting format. So in that format, an agent executes the actions. It chooses, passes the action output back, and then repeats. So in the pseudocode, what agent do is, so agent think, and then get action from its thinking. And after run or execute that action, agent will receive a observation back. And then with that additional information, agent will think again and then generate the next action. And then agent will think, all right, should I finish the loop and then return an answer? Am I confident to do that? If the agent is not confident to do that, it will continue this think, action, observation loop until it feels confident to break it, stop it, and then return the final answer. Cool. So this is actually a system prompt for a React agent if you want to use it. So in the first part, tell your agent to answer the following questions as best as you can, and tell your agent what tools it has access to. Google Maps and Google Search, that's our tools that's available to your agent. And then tell your agent to use the following format. So this is the format that we talked about just now, the thinking process, the think, action, observation loop. So first one is the question. In this part, define what input your agent will receive and what question you want it to tackle. And in the second part, thought part, encourage your agent to think step by step on what actions it needs to take. And in action part, tell your agent your action should just be one of the tools that we give you access to. And in the action input part, that is the input that you actually send to the tools. And then in the observation part, encourage your agent to conduct the think, action input, and observation loop if it is not confident of the result of the action. So that is the loop. So the next thought part is actually, after breaking that loop, give your agent a cue, right? The cue is, I now know the final answer. I will summarize the reason behind the answer, and then return the final answer. In that section, define your final answer output schema there, and then type begin. Also, give a placeholder of the questions or input. And lastly, define the agent's scratch pad for your agent to record its thinking process and intermediate calculation. So the scratch pad is just a temporary storage area. All right, so now this is a logging example that our QA agent gave us. So let's watch agent think, observe, and decide all together. So agent started to execute the chain, and then it thinks the two merchants have two different names, and they located in two different states. They also belong to the two different categories. One is the yogurt shop, the other one is a petroleum company. Therefore, it is unlikely that they are the same, but let me confirm. All right, so the action will be, I will now perform Google search for the first merchant. And next, the agent just get the yogurt land and its address as the search term that is ready to send to Google search tool. And after send that input to Google search, it receives a observation with types, website, description of the yogurt land. After processing that observation, the agent thinks again. The search result confirms that the first merchant is a frozen yogurt shop in Paramount, California. Now I will perform the Google search on the second merchant to gather more information. All right, so let's see. It is actually do exactly the same thing as this first merchant. It is quite amazing because you can see these logs. The QA agent is thinking like a human, exactly. So finally, it returned a thought that's saying, all right, so I confirmed the second one is a petroleum gas station that's located in Port Charlotte, Florida. So given that the two merchants are in different sectors, they are located in different states, it is clear that they do not belong to the same brand. So it is confident, and it returns the final answer. Right now, let's review some of the outputs. So in this table, the first two columns are merchant names for the pairs that we send to the agent. The third column is the true label of those pairs, and the fourth column is the response that the agent returned to us, and the last one is the reason that he gave us. So let's review the first one, Ritual Cosmetics and Rituals. The agent thought they are the same brands, and it is correct. So the reason that it gave is, both merchants have the same website and similar names, indicating that they are the same brand. Perfect. Let's review this one together. Prada Fitteds and Prada Mahasset. This is actually wrong. So agent labeled it wrong, and I label it wrong as well, unfortunately. I'm not 100% accurate. So let's take a look at why. Both merchants are associated with Prada brand, but they are not the same. Prada Fitteds appear to be a specialized Instagram account, while Product Mahasset is a physical store selling a range of products. So if you read this reason, you will think, it's actually give a pretty valid reason, because it says it's not the same, right? But for somehow, it fails to make a judgment. So it is actually possibly because the system prompt. We didn't clearly indicate what it means to be the same brand. So for example, at this point, you can go back and change your system prompt saying, hey, an Instagram account can never be the same as a physical store. So give your agent more examples to help it to understand. All right, the last one, Mazio's and Mazio's, I don't know, Italian eatery. So both merchants, they have same websites and they belong to the same brand. And also they share the same merchant category code, so it's perfect. All right. So far, you might have a basic understanding, the pros and cons of using a LLM agent, right? It is pretty accurate, as we reviewed before, like slightly similar to human QA performance, but it is faster for sure, and it's more cost effective. And it offers a broader coverage comparing to human human QA and programmatic QA. However, as you can see in that wrong example I showed you, it still requires some human QA. In our scenario, high accuracy, right? High standards. However, it is easier than the human QA because it offers an explanation, right? So you can just review the explanation rather than like a huge metadata table. The second disadvantage is it is quite slow, especially when you are using React agent. It is quite slow comparing to programmatic labeling because the React agent is conducting the thinking, action, observation loop multiple times until it is confident. And last is that output. Sometimes it is not always in the requested format, but like I think the day before yesterday, ChatGPT, like OpenAI just released another function that's called like structured output. So that might help on this. So yeah, model is changing every day. All right, so let's evaluate our options. So with a show of hands, which one would you choose? Manual QA, anyone? No. Programmatic QA. All right, yeah, smart. How about QA agent? Only 1, 2? Oh, okay, 4, great. All right, let's review the whole picture of the performance, right? From the time, cost, and accuracy perspective. So in our test set, we label 5,000 pairs using all 3 methods, and manual QA, unfortunately, took us 2 days to finish it. Quite costly, accuracy rate around 95%. Programmatic QA, that is much more faster, but due to the issue with underlying data set, it's around 90%. LLM QA agent took us like 6 hours, and accuracy rate is like slightly lower than human, but with more tuning on your system prompt, I believe it can reach to like a similar level as human QA. All right, we're almost there. So lastly, summary. We have the consensus that when data quality and accuracy is important, substantial time and efforts that need to spend and dedicated to QA. So what do? LLM agents plus programmatic labeling can reduce at least 50% of human QA efforts, depending on your threshold of accuracy for sure. But yeah, not try to put anyone out of their job, but it makes more sense, right, to go with LLM QA agent and programmatic QA labeling instead of just sending all the test set, all the QA set directly to the contractor or the QA team. But there are some exceptions. If you're labeling your data based on pure human experiences and there's no source of truth to pull from, it's a different story. All approaches require thoughtful design and iteration, which means, as you can see, for our human labeling and our QA agent labeling, we document specific rules, standards, and instructions for them. So that's what you need to design thoughtfully beforehand. And for the iteration part, it makes sense to combine all those three methods together to achieve the optimum QA accuracy. Lastly, it is also important to have a clear metrics for success and measurements of accuracy. So we see like no data can be perfect, no data can be 100% accurate, right? It is more important to know what your business wants and what your customer wants, and then spend time on efforts on that. Also, the accuracy rate that we've seen before is just like right now, at this point in time. Model iterates every day. So next year, I might say, the model will perform even better than that. So yeah, let's just embrace the change and make the QA process faster and more scalable. All right. That is all for today. Thank you so much for joining this session. I think I still have some time for Q&A, and if we don't have the time in the end, I'll be here, Coop, our CTO, Patrick, our lead of sales. We three will be around, so come and say hi and ask us questions, all right? So thank you so much, and now I'm ready for some questions. Yeah, go ahead. Thank you, thank you. All right, please.
Yeah, when you showed the example of the React agent,
Yeah.
in your code you had the sort of the condition check of whether the agent is confident above a certain threshold, and then it will output yes or no if it's 1 or 0 or something.
Oh, you mean the, sorry, you mean the prompt, right? This one? Yeah.
So how do you prevent that wallet from having an infinite loop where the agent is never confident?
So basically, you can tell your agent, this is just a pseudocode, so actually LangChain already take care of it for you. So I imagine in their source code, it must say, do not enter to an infinite loop, or just conduct a React think and action loop less than, like, say, 5 times. So you can always communicate to your agent what you wanted to do in your system prompt, right? So if you, so this is actually like the standardized React agent prompt that I fetch from LangChain. You can change it to whatever, right? So for example, in this observation section, it says, oh, this think, action input observation can repeat n times. You can say 5 times or 10 times to avoid the infinite loop. But it's a great question. Thank you. All right, please.
What's been some of the hardest parts about making the agent code work for you guys?
What is the hardest part?
The hardest part, yeah.
Yeah.
Maybe the group might be one, but anything else to do it.
Yeah, so hardest part will be, I would say, still the system prompt part. So just in the first, so just translate the standards from like the standards that the audience is like human labelers, right? You need to transfer that, translate that standards to an agent. And agent is not as smart as human, so you need to be very, very clear and specific for each step what you wanted to do, right? And for sometimes the product example that I showed, it still do not really understand what it means to be the same brand. So if you find some edge cases like this, you need to go back and then change your system prompt again until it gives you a pretty robust performance. And you also need to build some metrics in-house to evaluate if it is robust or not. So that is one part, and the second part will be it is pretty slow. So it's like an engineering effort that how to make it faster instead of, so you can just use concurrency or thread to trigger the, or like OpenAI offer batching options. So just like combine the data science and engineering efforts together to make it more fast and more scalable. Yeah, so that's two difficulties that we've seen. And the last one is the output parser. So since we developed this, it is, we still see some like edge cases that it returns something totally irrelevant, or the output format is totally out of range. So you need to figure out a way to avoid that as well. Yeah, please. Yeah.
The accuracy rate, is that all like GPT-4, or is that 4.0, or have
Oh.
you tested with other things, Sonnet or Llama 3.1?
Yeah, that's a great question. The question is for the time I listed here, which model I chose, and did I choose different brand, like except for OpenAI? The answer is this is a performance achieved by 4.0. So this is actually before 4.0 mini. So I would say this cost might change as well, because 4.0 mini is like 3% of 4.0, so it's much more cheaper. But we haven't tested the performance yet as we speak here. And the time, this is actually a part that you can combine your engineering efforts as well, like use batching or concurrency calling. So as we are the client of OpenAI, so unless OpenAI performs super bad, we will just try OpenAI instead of move to other providers. So thank you. All right, please.
Two questions, but very related. Obviously, you've got some 93% accuracy. What did you kind of see in precision and recall for those? And
Yeah.
related, you obviously got essentially it's a match or it's not a match. Did you also sort of have a third option for it's not confident in being able to say whether it's a match or not?
So the first question is, for the accuracy rate, you are curious about precision and recall. And the second question is, for match or non-match, is there?
Yeah, so you said like 1 or 0 to say whether or not it was the two merchants were a match.
Yeah.
Did you also have an option for it to say,
Yeah, yes.
that it's not a match or that it is a match?
Okay, so first question, the accuracy. So we actually conduct this, so we find actually half of the examples that is labeled by 1, and half of the examples that's labeled by 0 to conduct this performance checking. And overall, we didn't really recall or record our recall rate and precision rate, but because most of the cases that we send to our QA agent, they can be potentially labeled as 1. So there's an imbalance there, and it performs like similar on both of on those two. Although it's imbalanced, but it performs similar. For some very hard cases, like you should label them as 0. But agent or human label them as 1. It performed like similar as the hard cases in the 0 data set. So in short, we didn't really record those recall and precision, but they are similar to the accuracy rate that I provided here. And the second question is, tell your agent to label match or non-match. We do provide other options, like if you don't know, please return null instead of a guess. And also we try something like, instead of predict 0 or 1, please predict the similarities. like use, or just like say, if you think they are affiliated or they are related but they are not the same, please use 0.9. So you can tune on your own use cases. Great. All right, thank you so much. Thank you for your time, and we'll be around, and please come and say hi and chat. Thank you.